So the last section in this chapter now is about trapezoids. Quickly remind me, how do you find the area of a trapezoid? 1/2 base 1 plus base 2 times height. But bases will be parallel and perpendicular to the height. Okay. Very good. So there's two things that happen in here. We have the trapezoid method and the trapezoid rule. I'm going to briefly present the trapezoid rule, and then I'm going to tell you, don't learn this, because it doesn't always work. Trapezoid method is 100% guaranteed. So that's where we'll go. Using integrals to find area works extremely well as long as you can find the antiderivative of the function, but sometimes the function is too complicated to get the antiderivative. Other times they don't even give you a function to work with, they just give you data points or a picture of the curve, in which case antiderivative method will fail, so we need a way to do this accurately. Now earlier on we talked about LRAM, right RAM, and MRAM, and we said, you know, these aren't extremely accurate. To make them accurate, you have to increase the number of rectangles, and that becomes very cumbersome. So we want a better way to estimate the area under a curve, and to do that, we can use trapezoids. Now the trapezoid rule says to find the area using trapezoids, take h over 2, and then the first y-coordinate gets used once, the second y-coordinate gets used twice, the next y-coordinate gets used twice. They all get used twice until you get to the last one, where you only use that y-coordinate once. But the key is, this only works if all of the intervals have the same width. And that's not a necessary component of most of the problems you're going to run into. So if you don't have equal subintervals and you try the trapezoid rule, you're pretty much guaranteed to get the wrong answer. And it's not a good fit because most people don't stop to think about the width of the intervals. All right, so it gives us a better approximation than either the left or right rectangle method, even the MRAM method. But in order to use the trapezoid rule, all of the trapezoids have to have the same height. If the intervals are not uniform width, then you can simply use what we call the trapezoid method, and that means just drawing a bunch of trapezoids, find their areas, and add them together. A couple things to know. Heights can be negative in a trapezoid if you're using the trapezoid method, and one of the heights could be positive and one could be negative. That's kind of a strange feeling trapezoid, but it fits with what we're doing. Most importantly, though, sometimes your trapezoids turn out to be triangles. One of the bases has a length of 0, and so you have to treat that like that, and you end up with 1/2 base times height. So when you're using the trapezoid method, you might end up with a trapezoid that doesn't look like a traditional trapezoid. That doesn't really matter. All right. It is known that the trapezoid method turns out to be the same as left RAM and right RAM averaged, provided these are all the same number, and the function is strictly increasing or strictly decreasing, and the intervals are of uniform width. So you've got 3 conditions for this to be true. Don't rely on this fact. It's much easier to just actually know how to find the area of the individual trapezoids. Okay, so somehow my problems got out of order on here. See if you can find this problem. It's labeled as number 8. It's on the 3rd page. So we've got a continuous function from 0 to 6, has the table above. We want to use a trapezoidal approximation with 3 subintervals of equal length, and we want the total area to be 52. The question is, how big is this k value? So graphically, we're looking at something like this. We're going to go from 0 to 2, 2 to 4, 4 to 6, and we're going to draw a trapezoid from 0 up to 4, 2 up to k. So there's my first trapezoid. The second one goes from 4 up to 8, and the third one goes up to 6, 12. And the question turns out to be, what's the value of k? Now, if this is the point 0, 4, then this length is 4. The 0.48 means this length is 8, and the 0.612 means this vertical line has length 12. Let's look at the individual trapezoids.
Why did you draw a line? Make it up. How do you know to go this way?
Which way?
Why are you drawing trapezoids that way, going up?
Well, my curve goes through 0, 4, then the coordinate of 2 is unknown, but then 4, 8, and 6, 12. So it feels like this graph is increasing. It might not be increasing all the time, but it feels like it, so I've just drawn it that way. So let's look at the first trapezoid. The area of the first trapezoid is going to be 1/2. How long are the bases? 4 plus k, and what's the height? 2. Trapezoid number 2. 1/2. How long are the bases? K plus 8, and the height is 2. And in the last one, trapezoid number 3, 1/2 of 8 plus 12, and the height is 2. Now, if I add together all 3 trapezoidal areas, I'll have an approximation for the total area. Well, these halves and 2s are nice, convenient work-alongs. And if you notice, if you go back to that trapezoid rule I presented a couple minutes ago, what we said was the first height gets used once, then all of the other heights get used twice. Here's the k, here's the k, here's the 8, here's the 8, and the last height only gets used once. So if you know how to do the trapezoid method, you're doing the trapezoid rule correctly anyway. So what's my total here? 4 plus 2k plus 32?
Well, it would be
Nice job, Nate. 4 and k is 4 plus k. There's 2k. That brings us up to 12. 12 and 8 is 20. Another 12 would be 32. So in this problem, 2k plus 32 has to be equal to 52. And k turns out to be 10.
I think that's a point.
What would the average value of this function be on the interval here? Pardon me? No.
8/6.
No.
5/2. Oh,
Average value would be 52/6. Integral divided by interval. Area divided by width. They didn't ask that, but I did. All right. See if you can find this one. On page 2. So I've got a table here. Selected values for some continuous function are shown. We're working on the interval from 1 to 2. We're going to partition it into 3 subintervals of equal length. And they want us to calculate right ram, mid ram, and trapezoid. And then decide which one is biggest, medium, and small. Oh boy. Well, let's see. Let's do LRAM first. So LRAM, we're going to do LRAM 3. How wide is each rectangle?
Does it find out?
I'm stretching from -1 to +2, and I want 3 equal subintervals. They're all 1s, aren't they? So the width of each rectangle is going to be 1. Here are the 3 intervals, -1 to 0, 0 to 1, and 1 to 2. If I'm doing LRAM, what's the height of the first rectangle? 2. Use the left edge to calculate the height. 2. If I'm doing LRAM, what's the height of the second rectangle? 3. And if I'm doing LRAM, what's the height of the third rectangle? Say again? 0. So LRAM 3 turns out to be 5. Okay, let's start over. Next they want me to do midpoint. So let's do MRAM 3. Again, the rectangles are going to have the same width. Each one has...
for right.
Yeah.
I said that right away.
Oh, that's for right. Well, we'll have to come back and do that. We can get that. But let's get M, and then we'll get R, and then we'll get trap. I should have said that louder.
I tried to, but no one listened to me.
I was just rolling.
I said it these 4 times while I was doing all
So each rectangle has a width of 1. If we're doing MRAM, how tall is the first rectangle? 4. How tall is the second rectangle? 1. And how tall is the third rectangle? -3. So our total area here is 2. All right, Cody, we'll fix it right now. Let's do RRAM. 3. How wide is each rectangle? 1. And if we're doing RRAM, how tall is the first rectangle? 3. Second rectangle? Third rectangle? So RRAM 3 turns out to be -3. And finally, the trapezoids. 1/2, we got a bunch of parentheses to fill in. What's the height of each trapezoid? 1. What are the bases of trapezoid 1? 2 and 3. So that's going to give me a 5 here. What are the bases of trapezoid 2? 3 and 0. So trapezoid 2 is actually a triangle. And what are the bases of trapezoid 3? 6. Again, that would be a triangle. So I've got 5 halves plus 3 halves minus 6 halves, so -3 equals 1. So what do we have here? They want to know which is the smallest of, and we're not supposed to use L. Which is my smallest? Right. Net followed by T followed by M, which is choice A. In this problem, what is the average of the left and right rams? It does turn out to be the trapezoid, doesn't it? You did it that way? I'm leery of that, but it did work here. Oh, isn't this fun? Number 89.
That's on the same page.
What?
It's on the same.
Same page?
Just squirted water all over.
Out your nose?
It went like this. No,
Oh.
it just.
Ooh,
I've got extras. Table of values, continuous function. I want equal subintervals from 0 to 2. And we're going to do a trapezoidal approximation from 0 to 2. So how wide is each of my 4 trapezoids going to be? 1/2 plus 1/2. Oh, I'm writing way too big. So how big are the bases of trapezoid 1? Rachel, what are they? 3 and 3. How big are the bases in trapezoid 2?
3 and
How big are the bases in trapezoid 3?
5.
8. And how big are the bases in trapezoid 4? 8 plus 13. Now every one of these is some number multiplied by a fourth, isn't it? Let's just take that fourth out and simplify our complications. 3 plus 3 is 6. 3 plus 5 is 8. 5 plus 8 is 13. And 8 plus 13 is 21. 6 and 8 gives me 14. 14 and 13 is 27. 27 and 21 is 48. Divided by 4 would give me 12.
I really like that first rule you taught us.
Trapezoid rule. In this case, it works, doesn't it?
I'm gonna make sure it works every time, and I'm gonna use that if I have the opportunity.
What's the key to making sure it works, Cody?
If it has the same sign.
Equal subintervals. If you have equal subintervals, then it's a piece of cake. And I didn't even teach it to you. You just remembered that it comes back to once, twice, 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 once, right? There's the first 3. There's the second 3 twice. Here's the 5 used twice. Here's the 8 used twice. And the 13 used only once. So it's always the width of the subinterval divided by 2. And that's where all these 1/4 come from. H over 2. And then first is used once. Last is used once. All the others are done. So it's number 8.
Is it? What is difference to
Here we go. A left Riemann sum, a right Riemann sum, a trapezoid sum are used to approximate the value of the integral from 0 to 1, each using the same number of subintervals. The graph of the function f is shown in the figure above. Which of those 3 sums will give you an underestimate? Which of those 3 will give you an underestimate?
Because
Will left give me an underestimate?
I don't get the difference.
A left sum means that the left edge of the rectangle, the left top edge of the rectangle touches the curve. Left definitely gives me an underestimate, doesn't it?
where it's concave down is that.
I'd say trapezoid would too.
Does the right sum give me an underestimate? Well, the right edge has to touch. Does the right edge give me an underestimate? Not at all. And then the trapezoid, well, you'll be able to see this. I make some trapezoids here. Over or underestimate? Underestimate. Which sums give an underestimate? 1 and 3. No calculation at all. Everything done simply by inspection.
Wait, did we say trapezoidal does or doesn't?
Pardon me?
Trapezoidal does give you an underestimate or no?
Take a look.
So slightly.
It's an underestimate for sure. How are we doing for time?
5 minutes.
For 5 minutes. See, we got function f from 0 to 3. We want to integrate from, is it 0 to 3 or 1 to 3? I can't really tell on here. 0. 0 to 3. Which of the following is going to be the smallest value? The left sum, the right sum, the midpoint sum, or the trapezoid sum?
Oh wait.
Right.
It's 1 to 3.
1, 3?
Right.
Doesn't really matter. Which one's going to give you the smallest value?
Right.
Smallest.
Because it's the underestimate. It's the most underestimate.
Anybody want to argue with that? Nate, you want to argue with that?
I'm looking at it, I'm thinking. Can you use another point?
Which one do you think it is, Rachel?
Is the lowest value because
The left sum actually over approximates, doesn't it?
yeah,
The right sum, on the other hand,
definitely underestimates.
definitely underestimates.
The
So we know
trapezoidal-
it's not left.
The trapezoidal is
Trapezoidal is going to be pretty close.
and so will midpoint.
And midpoint is going to be pretty close. So I think you're right. I think it is the right side one that's going to give you the worst approximation.
Is it bad that we can just do it by inspection? Or should
No,
we
they're,
do
some of these are conceptual questions. They're meant to be done by inspection. By the way, one of the choices is the actual value, but we would know that the right sum is less than the actual value, correct? Let's do one more. Let's go to this, and we'll call it a week. Is part B circled on that?
Yeah, squared.
Squared, that is circled in, squared in. Using correct units, explain the meaning of the integral from 20 to 40 of v of t in the context of this problem. Then use a trapezoidal sum with 3 subintervals indicated by the table. What does that mean? The subintervals are going to be indicated by the table.
Oh, so don't use the trap.
Don't use the trapezoid rule. They might not be of uniform width. And notice we're only going to integrate from 20 to 40. We're only looking for that part. First question, what is the meaning of that integral?
Distance in meters.
Not distance. Displacement. Think back to the very first thing I said when we started chapter 5. The very first handout you got, there was a sentence at the top, and I said, let's always try to keep this in mind. The integral of the rate of change of f yields net change in f. This is the rate of change of position. The integral of the rate of change of position would yield net change in position. Net change in position's term is displacement. So using the correct units, what do we have? A displacement of so many units measured in meters over this 20-second time interval. Do we have the number yet? We are going to use 3 trapezoids. One half plus 1/2 plus 1/2.
Can our subintervals be negative?
Nope. First subinterval stretches from 20 to 25. That's going to be 5. Second subinterval is 25 to 32. That's going to be 7. And the third subinterval is 32 to 40, which is 8. Those are your 3 individual heights. Now, how long are the bases? 10 plus -8. Second one? 8 plus -4. And the last one? Oh. -4 plus 7. Now, what a massive headache that calculation will be. Tell me something about this calculation that I really want to hear.
All the halves together.
I don't have to do it. This is a number.
Ah.
Nobody said I had to simplify my numbers.
Right.